Okay, so today we'll see the proof of another standard limit, so which is so this is the proof we are going to find, we are going to see. So limit x tends to 0, 1 plus x whole power 1 by x is equals to e. What is the meaning of this? Imagine this is all a function, okay? When x is tending towards 0, when x is approaching 0, this is a function. This function will approach, or this function will reach which value? Okay, that is what we call it as limit. So that means whenever x is tending towards 0, this whole function, this function is going to reach e. So e is the limit of this function. So we need to prove this. Okay, see once again, limit, whenever x is tending towards 0, x approaches to 0, then 1 plus x whole power 1 by x is a function which leads to or approaches to or reaches to which value? That value is e. So this is what we need to prove it. Now generally to prove this, to prove this, uh, see, to find the limit of any function, what we require is, what is the basic method? We'll substitute. If we substitute, and if at all, or if we receive, or if we get any indeterminate value like 0 by 0, 1 by 0, or 1 power infinity, or 0 power 0, okay, or infinity minus infinity. If you get these kind of values, then by doing a simplification, by doing a factorization, or by doing a rationalization, or by applying a standard limits, we'll find the limits of that function. So the basic thing is we have to verify whether in the substitution method is it giving any indeterminate value. Okay, so first basic thing is we are using a substitution method to find the limit of this function. So generally, what do you mean by substitution? X tends to 0 means I will substitute x value 0 only. So if I substitute x is equals to 0, this function is going to change like this: 1 plus 0 whole power 1 by 0. So 1 plus 0 means which is 1. So 1 power 1 by 0 value is infinite. So therefore 1 by infinite, we are getting something called 1 by infinite, and this is the indeterminate form. What is this? This is the indeterminate. We can't find the value of 1 power infinite. So as it is giving an indeterminate form, okay, so substitution method is failed. So therefore we need to do some kind of factorization. I don't think factorization is something which is going to help us here, okay. And rationalization, even rationalization, factorization, you can't see it because there is no irrational number here. So even rationalization is also not a best technique to follow. So what is the way? Okay, so as it is giving an indeterminate form, okay, we need some way, we need some kind of simplification, otherwise we can't find the limit of it. So therefore what I am going to do is, see, generally here what exactly we are doing, we are finding a limit for this function. Okay, we are finding a limit for this function. For a particular function, when the limit will exist, okay, to a function, the limit will exist only when the left hand limit and right hand limit is equal. Okay, so whenever it is giving, whenever the left hand limit value and right hand limit value is equal, then it gives the, I mean that limit, the left hand limit value and right hand limit value, if they are equal, then that limit is the limit of that function. So what is the basic thing? Okay, I am going for, to find the limit of this one, first I would like to see whether the limit will exist or not. Okay, to do that, what I am going to do is, okay, so I am going to find the limit. I am going to find the left hand limit and right hand limit for this function. See, I am doing this all because all these methods are going to fail. And lastly, we are going to find the approach. See, it is not important that we are directly landing to the right answer and proving it. So sometimes we need to do an experiment. Why can't we do this? Why can't we trial with this? Okay, so in the trials, I mean, what we need to understand is sometimes the trials will leads to a new method, or maybe it fails, or maybe through the trials we may not get the answer, but it will help you why you are not using that method. So for that reason, I am going to find the left hand limit and right hand limit for this one. So generally, left hand limit will be denoted or can be written as what? Limit x tends to 0 minus, and here we'll write the function. So that is which function? Let's assume this function as f of x for some time. Okay, because writing this function is difficult all the time. And how to, so this is the symbolic form or mathematical notation of left hand limit. But what is the answer of it? Okay, whose answer is, I mean, how to find the left hand limit? Limit h tends to 0. Okay, here f of x value, so here h tends to 0, f of a minus h. This is how we'll find the left hand limit of any function. So now we need to find f of a minus h. Here, what is the value of a? See, this is when this is, I mean, when this answer is going to come, whenever the limit is limit x tends to a, f of x. If I wanted to find the limit for this f of x function whenever x is tends towards a, okay, this is how you will write the left hand limit, and this is how we will find the value of it. So here x is tends to a. If x is tends to a, we will write a minus h. Here x is tending towards 0. So therefore we need to write here this one, we can write this as limit h tends to 0 and f of 0 minus h. So this is how 0 minus h, it means to say that limit h tends to 0, that is f of minus h. So in place of x we should substitute minus h, and then we need to approach it. Okay, so let us try the same way. Okay, so if I try to find that, what is going to happen? Let's try that. Limit h tends to, okay, let's find first f of minus h value. See, we have f of x. What is the f of x here? F of x is equals to 1 plus x whole power 1 by x. So this is the value of f of x. Now therefore equals to 1 plus x value. So instead of x we should find the f of minus h value, right? So let's find out f of minus h value. So f of minus h is equals to, so what do you mean by minus h? In place of x we need to replace with minus h. So 1 plus x place, what we need to write? We need to write minus h whole power 1 by minus h. And next, so this is the value of it, and if you simplify this one, you will get plus into minus minus 1 minus h whole power minus 1 by h. So this is the value of f of minus h. Now if I substitute f of minus h, so this is all the simplification that we have done to get this f of minus h. So here limit h tends to 0, f of minus h value is how much? Limit h tends to 0. So 1 minus h whole power minus 1 by h. So 1, now I am substituting, because finally to find the limit of any function we need to substitute. So therefore I am substituting 1 minus 0 whole power minus 1 by 0. So 1 minus 0 is nothing but 1. 1 by, this is minus 1 by 0 means it is minus infinite. So once again we are getting an indeterminate form. Even with the right hand limit also we are going to get the same. Okay, maybe you will get plus h, not maybe, you will get 0 plus h, here plus h, you will get 1 plus h, you will get 1 plus 0. Again what are you going to get? So you are going to get, your right hand limit is going to be how much? 1 power plus infinite. But still this is an indeterminate form. So even, I mean, the left hand limit and right hand limit is also giving an indeterminate thing. So this is the reason why, I mean, you cannot decide by doing this, you cannot decide that there is no limit will exist for this function. Okay, so there is a bypass method, there is a different way to solve this method. So what we understood from this one, I mean, left hand limit, finding right hand limit is also not going to help you to find the limit of this function. So what is the way? So the way is this one. See, I am going to do something like this. See, but one thing is clear, the only thing is the approach we need to change it. Okay, because whenever you see this 1 by 0, then automatically it leading to a indeterminate form. So therefore, we should change an approach. So what I am going to do is let see, if you look at this, I mean, don't depend on the answer, so that you can go like that. Okay, I'm sorry. So let's take 1 by x. Let's take 1 by x and whose value is equals to n. So I'm just assuming the 1 by x value is n. So if 1 by x value is n, now how the equation is going to change? 1 by x is equals to n means x is equals to what? So x I am transferring to this side and n will come to this side. So it will become what? X is equals to, or let me write one more way, 1 by n is equals to x. So in place of n, sorry, in place of 1 by x, I can replace with n. In place of 1 by n, I can replace with x, and we'll see what is going to happen with this. Limit x tends to 0. Okay. So x we can also write as what? 1 by n. 1 by n, because x value is 1 by n, right? So 1 by n is tending towards 0. 1 plus, so this x place, what we can write? X place we can write 1 by n. So 1 plus 1 by n whole power. Okay, this 1 by x plus what we can write? We can write n. And actually this is a very interesting thing. Okay, first I will take the calculator and I will calculate it, because we need to find the value of it. Okay. Yeah, for calculation's sake, I have taken this. See, we need to find the limit of this function. To find the limit of this function, whenever 1 by n is tending towards 0, that means whenever this value 1 by n, this portion of value is going to or reaching to or trying to move towards 0, then this whole function is going to reach to what? That is what the meaning of this meaning of this limit. See, once again, whenever 1 by n 1 by n is going towards, is approaching 0, then what is the approached value of 1 plus 1 by n whole power n function? This function will lead to what? Whenever this 1 by n leads to 1 by n leads to 0. Okay, so to understand that, okay, let us take n is equal to 1. If I take n is equals to 1, it will become 1 plus 1 by 1 whole power 1, and this value is 2. Next, I am taking n value 2. So what did you observe here? Here first this 1 by n value is 1. Now it became 1 by 2 in the second case, and it became 1 by 3, and in the third case and fourth case it became 1 by 4. Fifth case it will become 1 by 5, 1 by 6, 1 by 7, 1 by 8. Okay, I mean, in this way it is actually leading to, if you observe here, 1 by 1 is a bigger value, 1 by 2 is a smaller value, 1 by 3 is even more smaller, 1 by 4 is even more smaller, 1 by 5, okay, it is becoming smaller and smaller and more smaller, and there is a time, okay, there is a time it will reach to 0. That means this 1 by n value, if at all it reaches to 0, then 1 plus, okay, this whole function whole power n will become what? That is the question. So this is going to become something a bigger value. Okay, so therefore there that is going to reach which value, that is what we are discussing. So first one n value, when you take 1, it is 1 plus 1 by 1, that is 2. 1 plus 1 by 2 whole power 2 is equal to what? Okay, you will get 3 by 2. 3 by 2 whole square is 9 by 4, which value is 2.25. Now n is equal to 3. 1 plus 1 by 3. See, this n by 1 by n value we are decreasing. First it is 1 by 1, 1 by 2, 1 by 3, and this exponent is increasing. Okay, n is equal to 1, 2, 3. Exponent is increasing, but whatever the number we are adding to 1, that means that 1 by n, okay, is decreasing. It is decreasing, more decreasing, and decreasing up to 0. If I deduct this 1 by n value, or if I deduct this 1 by n value till 0, then what is that value? Okay, so if I just go on in this manner, okay, you are getting 6 by 5 whole square, 2.484832, and so this value is actually very very closer to e value. It is going towards e value, 2.71828. Okay, so that means the more 1 by n value, the more number of 1 by n values, that means whenever you decrease more 1 by n, okay, this function is going towards 2.71828. so this value is going towards what? 2.71828, and so on. It is an infinite series, because you will never, if I give 1 by 6, 1 by 7, 1 by 8, 1 by 100, 1 by 1000, 1 by 1 lakh, okay, actually you are going very very closer to 0, but you are not going to become 0. But if at all, see, 1 by n, that is the reason why 1 by n is not equals to 0. 1 by n is going towards 0. Whenever 1 by n is going towards 0, what is this whole function will goes to? So it will goes to, it will reach us to 2.71828 and something like that. Okay, it is a irrational number, and this value is equals to e. This number is called Euler number, or we can also call this as a Napier constant. Okay, we can also call it as Napier constant, and that means this whole function will give or approaches to e value. So this is the reason why limit extends to 0, 1 plus x whole power 1 by x is equals to e. Compared to all the proofs, this is something related to the inference, or you need to think about it. Okay, you will not land to the answer, you need to think about the answer. Okay, so that is the difference in this proof and all other proofs. Okay, so I hope you understood. Thank you.